My name is Suchay Dharnidharka. I'm from Dublin High School, and I'm in 12th grade.
Hello, my name is Kaushik Indukuri. I'm a junior in high school as well, and I'm from Dublin High School.
Hello, my name is Nitin Indukuri, and I am a senior at Dublin High School. And our project is called Spacious. So we are focusing on NGN goal number 18 to protect Earth from hazardous asteroids and interplanetary defense. So our project is a STEM project, and we would like our judges to be social impact entrepreneurs today.
Okay, so the problem is that there's a lot of space debris around Earth, and people aren't really aware of the problem that it presents, and many space agencies are neglecting to do anything about the space debris around Earth. So right now, the space debris around Earth can not only disrupt future space missions, but it also puts people at risk because of the debris that could enter Earth. In the last 50 years, at least one piece of debris has hit Earth. And in reality, the number of debris per day can be from 3 to 500 metric tons around Earth. The speed of the debris can also reach up to 17,000 miles per hour. And even if a single piece of debris were to hit a populated area, it could prove devastating.
So our solution is a space collector. So the way that the space collector works is it has a funnel at the very front of it. So as it enters Earth's orbit, it constantly revolves around it. And as it revolves around it, it collects every space debris that it finds in its path. So by collecting everything into it, the first stage would be the compressor. So the compressor, as you can see in the top left corner, works similar in that way, but for this model, I built a temporary expansion mechanism, which can push the compressor to one side of the system. So by compressing the space debris that we collect in the collector, we're able to save space and collect a lot more during its orbits around Earth. And once it compresses it to a certain amount, then there are conveyors at the very bottom, which push the space package back to the back. So as you can see in the top bottom left corner, that's a storage area for these debris packages. And we can store up to 3 of these debris packages. And so once we collect this certain amount, we're able to then make it back to the International Space Station and dock. So the way that our collector docks is at the back, there is a hatch which connects to one of the hatches at the International Space Station. And so our model is actually 1/16th size of the actual model that we would want to be building for space. And so by just scaling up our prototype, we're able to perfectly match what we want in real life. And the way that we would remove all this debris packages would be opening a latch at the back, and an astronaut that's at the ISS could come and remove all the debris all at once. And we could then take all this debris back to Earth and reuse all the materials that we've collected. And since our collector is completely autonomous, it relies completely on solar power to be renewable and reusable.
Okay, so our call to action is that we want to spread awareness to people that so that space agencies will stop neglecting space debris around Earth. So we want to actually partner with agencies so that we can integrate our collector with their missions, so that we could essentially deploy the collector while they're on another mission, let's say to Moon or to Mars and whatnot. Currently, there's $300 billion worth of space debris around Earth, and we want to collect this debris and reuse it so that not only does the space agency save money, but it also helps the environment. So our proposal is worth about $325 million as seed money, and this not only includes the material cost of the actual collector, but also labor cost and the cost to actually launch into space.
All right, so moving into the financial model. So we have the material cost of the actual collector, which ranges from around 175 to $250 million. So the reason it costs this much is because we use the satellite as basically a model of comparison with the actual model that we have here for our debris collector, because it kind of has the same type of size and has just as many things on it as the satellite does. So our business model, and not to mention, we also have the actual compressor, which actually adds on to the cost. But the thing that's important about this is that in the long run, the space agencies would actually be saving more money than they would actually be losing. by reusing the materials that they actually lost, in space. So it costs around $90 million for the Falcon 9 rocket. Most of our money goes to assembling the collector in space and the extra weight added to the rocket being sent up. This would actually save around $100 million through this method. Basically, if rather than sending it out separately on a separate mission, so it would be better and more efficient if we sent it along in a specific mission done by NASA or some other program. So going off of NASA is sending rockets on Artemis mission to the moon, and we could implement these collectors on these rockets to save both money and resources. And then this goes back to the amount of debris. So there's, like Kaushik said, $300 billion worth of space debris. And by collecting the space debris, the space agency can reuse the scraps for future rockets, ultimately saving them more money. And as a result, the marginal benefit with would actually increase as they continue to use this. So moving on to the sales and marketing. So what essentially is the main focus of our sales and marketing would be the utility patent that we have on this debris collector. So what we intend to do is to go to these different agencies and give our sales pitch as to why they should be using this product and why it is better than the other products that are currently out there. And essentially what this would do is they would be the ones who would be mass producing them, knowing that we have a specific prototype that they can use as a base. We don't need marketing as much, in the long run. For the partnership would be the main way that we would be earning money. Our source of rent, like I said, would be from the partnership. And yeah.
So our competition analysis. So during our research, we found out that there are 2 other companies that were focusing on clearing out space debris. So one of these companies is Surrey. So Surrey developed a net system which would automatically shoot a net once it sees a debris. And once it catches that net, it reels it back into the system. And the whole system as a whole enters Earth's atmosphere, and over time it slowly burns up. So when that happens, it completely destroys the whole system, but it also destroys the debris. So some of the reasons why our prototype and our concept is better is because we don't destroy our systems or collectors in the process of collecting some of this debris. And instead, we want to also reuse the debris that we collect into future goals. So by reusing this debris, we're able to not only save what costs we spent into it, but we will also gain back investment profits. So another company that we found was Clean Space. So Clean Space is a similar type of system like ours. It is a robotic collector which analyzes debris and collects it. So the difference between the Clean Space and ours is that Clean Space is completely only collecting, and our device actually has a compressor which allows us to intake more storage and rely less on energy. So any more information on Clean Space is not unknown. So we still don't know what will happen to their materials and what happens to all the reusing aspects of what they want to do. But they still haven't launched, and they plan on launching in 2025. So lastly, our summary. So our solution basically compresses all the space debris that it collects, and we reuse all the compressed space debris by sending it back to Earth and potentially sending it back into space for future space exploration missions. So it benefits future space exploration because the less debris there is in orbit around the Earth, the better the chances of not getting any interactions with any rockets going to farther away missions like Mars. And it not only helps space, but it can also help the Earth because we reduce the chances of any type of debris hitting the Earth. And so our profits and our business plan, like we said before, is basically based on our partnership and our actual concept outline and utility patent. So by implementing all of this business plan and getting a good partnership with any type of space agency, we can be profitable for both them and our company. So do you judges have any questions for us?
I do.
Yeah, go ahead, Steve.
Oh, this is Rob. How did you guys come up with the $300 billion figure for space debris?
So we actually did a lot of research online about all the past missions that went up to space, and also a lot of the satellites. Like a lot of the satellites that go to space, they don't remain perfect forever. They essentially like sometimes lose different parts. Some of them get destroyed, and a lot of maintenance is required for the satellites. So the majority of the scrap metal and space debris is from satellites that revolve around the Earth or orbit around the Earth. And not only that, there's hundreds of satellites around the Earth, and each time that each time that we go up and we try to do maintenance on the satellites, it sometimes space debris gets leaked and it gets escapes away, and this only increases the amount of space debris around Earth.
And an estimated cost of one satellite would be around $250 million because of all the electronics and all the equipment that has to be sent up there, and along with all the labor costs and everything.
Got it. Okay.
I would actually like to add on to that. And basically, a lot of this research, basically it shows like this approximation was made by satellites themselves, which actually, some of these satellites, which actually calculated the amount of debris that was there. So it's basically an approximation. So it's not entirely an exact number.
No, I get that. I appreciate the answer. Just a follow up. So let's take that $300 billion of space debris. Do you guys have any calculation in terms of, because it's not 300 billion immediately, right? Because you actually have to tear it down. You have to recover the pieces that you can and stuff like that. What is the cost of recovery?
So the physical collection using our space collector, or like the sending all the debris back to Earth and that process?
So what I'm asking is, once you've collected this, I'm assuming some cost to send it back to Earth, and then once you get on Earth, you have all this stuff of which you will probably have to tear down and get it down to components, or get it down, where you have to break everything down so that you can collect the things that are usable, or melt the metal, whatever, right? There's a cost of recovery. I'm trying to understand what that cost is.
So that cost is kind of similar to actually sending up our collector, because when we send up any of the astronauts or other people to Mars or the moon during these Artemis missions that NASA's sending up and other companies, so during those missions, they are going to be sending up a lot of people. And so when they're sending up all of this, we could also send up our collector. And how our actual collector is sent up is similar to how we're going to bring all the space debris back, because all these people that go up have to also come back to Earth at some point. And so all the space shuttles that are up there could, when they're coming back, are going to be collecting all the space debris and bringing it back.
Wait, are you asking about like actually like melting down the metal to like create the new rockets? Is that what you're asking?
Yeah.
Oh.
So actually, we didn't really deal with that particular calculation, mainly because we assumed that the materials would be directly brought down to the space agencies, which would communicate with the manufacturers. So what we know is that NASA, right, works with other manufacturers, right, in order to get its specific, things built. So we didn't necessarily focus on that aspect of, the cost calculation, because we're not necessarily dealing with that. We're mainly dealing with the patent and the actual sort of
basically the delivery of the system up to space.
Yeah, collecting the resources.
Mark, you have a question?
Sorry, one of the things that people like to do with collecting debris is avoid damage to existing satellites and to space missions. Have you thought about that as a value proposition as opposed to more or less a recycling activity?
We knew that space debris was would create problems for future missions, but we focused more on the future missions rather than satellites, because the future rockets, the more space debris increases, the harder it gets for future missions to like navigate through the space debris. And that's where we thought our main proposition will get, but that also will increase our value proposition.
Okay.
Gentlemen,
Yeah, go ahead.
well done. Are you familiar with XPRIZE, xprize.org? So the founder of XPRIZE is an astronaut and someone I know. Let me know if you're familiar with it, and it may be worthwhile to be part of their next competition.
Yeah, that's
Okay.
great. This is great, Hiba. So I think I appreciate the judges giving your connection. This is good. Yeah. So I definitely judges yeah. So definitely team. Well done. Job well done.
Okay.
We need to move on. Thank you very much. Please leave the meeting. Thank you.
Thank you guys so much.
Thank you.